Good morning, everyone, or afternoon, evening, wherever you are. But welcome to the 3D Printer OS webinar on education, use cases and tools. To introduce from the highest level, I'm Aaron at 3D Printer OS. To give a quick background on myself, I saw 3D printing for the first time about 3 years ago. I remember my teacher. I saw a gentleman by the name of Steve Heath in Newport, Rhode Island. And he was teaching a class on 3D printing. I had the chance to see something get made out of thin air. I had a chance to learn some of the software, the tools, and from there just took over my mind. It's something I ran with over the past few years, and bringing this, giving it back into that education piece is something near and dear to my heart. I'd like to also introduce Charles, our other panelist today. Charles.
Hey everyone, my name is Charles. I work for 3D Printer OS. Similarly to Aaron, I was introduced to 3D printing via a friend. Actually, a work friend sent me a link one day and was like, dude, look at this. And I couldn't believe my eyes. And ever since the first time I saw 3D printing, I've been absolutely obsessed with it. Absolutely love 3D printing. And I've been doing it for about 2 years now, and working with 3D Printer OS, work with a lot of schools, and absolutely love it.
Now, to give an intro on kind of the format for this webinar, I think it's your top right portion of your screen. You should have a little question mark. Now, that question mark is for putting in questions that we can answer as the chat goes through. We're going to stop at certain points and really solicit questions from you guys too. We'll try to make this as interactive as possible because there is a lot of questions, and we know we're not going to possibly get to them all today. So I want to say now, any questions we don't get to, you could reach me at aaron@3dprinteros.com, Charles at 3dprinteros.com, and we'll do our best to get to questions now or in the future. But again, throw them in there. We'll do our best. Additionally, today's theme is education, use cases and tools. The reason we're diving into this is we've been working with hundreds of schools across the country. We've had a chance to talk to a lot of different ones on what they're using, what's worked best, what printers, what hardware, what software. And we just want to kind of discuss what we found, see if that can help you, and maybe hear what you found. And maybe we can all kind of learn together from this. Charles, if you want to kind of segue into the three tiers we're going to discuss today, we'll begin.
Yeah, absolutely. So part of my position here at 3D Printer OS is to work directly with schools. So I've probably spoken to between 200 and 300 schools in the past couple of months, and the one thing that I do know is that every single school is doing something different with 3D printing at a different level, whether they are looking to get into it, have one printer or 50 printers. So of everything that is completely different with schools, there is some things that remain constant, which is what are the things that you need in order to do this, in order to accomplish implementing these programs into schools or into your community in general. And those three things that we've come up with today are content, hardware, and software. So that's kind of what we're going to be. That's going to be the high level overview of what we talk about today. And Aaron, I don't know if you want to begin by speaking about some content or.
Absolutely. So the first category we're going to tackle. So, I know a question that's going to come up today is what is the best printers? What's the best software? Like what should my school use? We'll get to that. And if possible, let's keep the questions kind of specific to the area. I want to talk first about content. What is needed to really bring 3D printing into our school? Because you can't just tell as a school, you can't say, oh, we want a 3D printer. The question is, what are you going to do with it? So it's really important to have a content or a curriculum strategy that you can bring in as part of the initiative. If there's anyone who's joined us today who has their own curriculum or content strategies, please either follow up with us or put your questions in there. I want to hear about them. But we're going to share today some of the ones we've heard of in hopes that maybe it'll help you or inspire an idea that helps you with your school. Now, one of the first ones I like jumping into is when I was in school, whenever we had a project or a science fair, we made a poster board, like a 2D diorama or whatever it was. That was our project. 3D printing in some of the schools we worked with has replaced the diorama. Being able to say if I want my students to create a Mars colony, like a presentation on what it would take to make a Mars colony, a 3D printer can be pulled in as a tool. Maybe the students can design and iterate their own moon rover. And instead of, just grading the students on like, hey, you've made a poster board project the night before it was due, which unfortunately is all too common. It's how many iterations of the moon rover were you able to make? Did one of them roll successfully? How would this one withstand different conditions? How would you design this differently? If it wasn't a rocky surface, if it was like a watery surface. And we've seen this curriculum, this is going to sound crazy, but with 7th and 8th graders. I mean, to me, that's beyond what I knew how to do in 7th and 8th grade. But with 3D printing and a content strategy for advancing that, these students are having access a lot sooner. Now, that's just one example. And Charles, if you is there any particular use case you want to share on the K through 12 side? And we'll move forward into universities, but let's start with the kind of primary school K through 12.
Yeah, the way I see it is I think K through 12, especially, in the introductions of 3D printing, I think finding the right content is probably one of the most important things, because if you're an educator, or you're an admin of running these programs, to teach individual students design software is fantastic, but to really get them to understand 3D printing and to really embrace it, to have good content, good material that you can kind of download off the internet, that's going to apply to the classroom and still, 3D print well. And there's a lot of different resources out there that are pretty awesome. One of my favorite is the Smithsonian. So if you go to the Smithsonian website, there's actually a 3D printed content section where you can get things from human anatomy to artifacts printed. I think one of the first things I printed was a woolly mammoth, which was actually a pretty difficult print, but you actually get the full woolly mammoth skeletal structure with a lot of supports. But I mean, from an educational standpoint, you could really fill almost an entire semester just with the content that's free out there, whether it be Thingiverse, which is not always guaranteed content, but you have great resources like the Smithsonian. We work very closely with a group called My STEM Kits, which is actually packaged curriculum. So it not only is it content, but it's actually curriculum to help the teachers teach it with 3D printing. So it's very much STEM and STEAM focused and oriented. So where they're actually printing out things that students can build with the 3D printers, whether it be catapults and different, scientific, research as far as, leverage and whatnot. So there's really great curriculums out there at super, super low cost that make it as easy as could be for teachers to kind of pick this stuff up without any design knowledge.
And before we dive more into content, I want to use this as a stop point. Is there any questions just kind of on this initial stuff? So we make sure before we kind of move forward on content, we get to anything. Again, in the upper right corner, there's a question button. Feel free to submit a message. And if there isn't any, I'll kind of dive more into different pieces. All right. I don't see any as of yet, so I'll keep going. But Charles touched upon Thingiverse. So Thingiverse is a unique tool also in the respect that I've seen some of the schools we work with using their files for body anatomy for printing out hands-on models that can be used within the classroom. And not just printed by the teacher, but printed by the students, which is quite powerful, because it's one thing to give a textbook, which is, great. And a student can flip through and they can see what a human, what a skeleton structure is. They can see what the brain structure is. And it's, you flip the pages, you move on. It's a whole different type of curriculum when you get to the section on the nervous system, when you get to the section on, how the brain functions, you hand them a brain. Obviously it's not a real one, but you hand them a 3D printed brain, which can be, printed in 4 sections. And this is a free file. I went and researched this morning and saw it was available. Same thing with the heart. The heart, even to me, it's a huge mystery, but being able to 3D print it and bring that into the classroom and put it in different pieces that the students can then assemble and understand, real time kind of what the size of an adult human heart is, it's powerful. Those are the things people remember. Just hang on one second. The question here is, do you think 3D printing hardware companies should be providing curriculum and content with their printers? That's a great question. Do I think they should? I think it would be terrific if they did. I don't know if I have an opinion on whether they should or not, because I'm not sure if they have the resources. I think great content comes from people who understand curriculum and know how to build that. I think there's some companies that have started to spring up who are focused on building, STEM and STEAM compliant curriculums that can maybe be packaged with a printer. I mean, we're going to dive into manufacturers, but even off the top of my head, I know, Ultimaker has a Create initiative. MakerBot has a schools initiative. 3D Systems has a schools initiative. So they have the concepts in place. I'm just not sure, a curriculum isn't always one size fits all. So do I think they should be providing content and suggestions? I think that'd be really useful, and it would help both, purchasers or printers and the manufacturers. But I think also it's on, forward-thinking teachers, forward-thinking, curriculum generators to also help with this. It's not it's going to need cooperation across both sides. But great question.
I agree with what you're saying, Aaron, exactly. And, Aaron and I might not necessarily agree on everything, but I think the content as far as like curriculum, again, like Aaron is saying, everything might be a little bit different. Every teacher, there's not a one size fits all curriculum, but I do think that it is the response that it could be or should be maybe a responsibility to at least offer those resources or have resources available, meaning it is difficult, especially if you're in a position as an educator to, what is the right 3D printer? That question alone is hard to answer all the time. And then what content do I use? And then what curriculum do I have? It would really be nice. And I think it would be forward thinking for the industry. And I think it would probably move the industry forward quicker if each of the manufacturers took a role in providing this content and the curriculum. So I think that it's definitely something that we're leaning towards. And I think over time that manufacturers will all eventually pick up on the content game and curriculums.
And one last piece on that for that question, after this, webinar is over, we always kind of send out an email with a list of resources. We'll make sure we send out a link to one of the curriculum providers we know who does a terrific job, and all the ones we know. That way, if you have any further questions or like to look at maybe a 12-week curriculum, you can take a look at that. Did I see another question come through? Yep, I'm sorry. So the next question was, how large can you go with one piece with today's printers? That's a great question. So I'm going to kind of answer this more in the hardware part, but I'll answer a piece of it now. You're only limited by the printer size. And in regards to desktop 3D printers, which are accessible in the classroom, I've seen 2 feet by 2 feet. There's some quite large models, and there's bigger models. You're just now limited by price. When we get to hardware, I'll dive more into that. I just want to stick with curriculum for a little bit longer because, we've discussed K through 12. There's also, some really interesting things people are doing in the kind of university space. Charles, is there anything else you'd like to add on K through 12?
I mean, I think from a general overview, I think we covered most of it from the standpoint that I know it's important. The curriculum for K through 12 is probably the most important part of it, like the content, because the printers are out there. And the software is out there, but I think one of the most difficult things is that content. And that's something that, again, that we're going to do everything we can to give those resources out. I think it's super important. And I think it's super important for K through 12. I think that's the best place to start with 3D printing, meaning if students don't see it till college, there's a learning curve there. But I've seen kids pick up 3D printing in 3rd grade, and by the time they're in 5th grade, they're doing things that I couldn't even imagine. So that's kind of where I am on K through 12.
Okay, and we could circle back to this at the end for general Q&A, but otherwise, we'll move kind of into the universities and the curriculums we've seen there. To start with, the universities, every single one is using 3D printing in very different ways. Where traditionally when I really started into this, I always thought, it's an engineering focused field. I was wrong. I was very wrong. 3D printing has wide sweeping applications beyond, engineering curriculums, but it has a really firm place in design and architecture and any sort of artistic focus. It has applications really across almost any sector kind of a university. Now, to talk about, and I guess some of the non-traditional ones I think about is think of a medical school. 3D printing. One of the use cases we've seen is a semester-long class within a medical school where students are 3D printing jawbones and they're 3D printing different medical files, again kind of on the earlier stage, to really real life mold and understand how, surgery time is affected by different processes. And that's a medical school use case. Now, diving into kind of a design school use case, we're seeing people either, print, miniaturized versions of models, but which used to instead be outsourced and made or created by hand by someone else. They're now able to print them and iterate throughout the semester as they refine their designs. From a use case standpoint, it's allowed them to really accelerate A, their learning process, and B, how fast they can iterate on the design side. Charles, if you'd like to go kind of more into the universities.
As far as the design side is concerned?
Just broad sweeping. You can go through some of the use cases of schools we've talked to.
So yeah, universities again is probably the biggest diversification of use of 3D printers. I think it's very rare these days that I call or speak with a university that doesn't have at least one 3D printer. Whether it's being used or not is a question. Like you're saying, Aaron, it's definitely not confined to engineering programs anymore. I think libraries all have one or two 3D printers, from the standpoint that, a call library, they have a 3D printer. Well, it gets used every once in a while, but you don't really have that champion often sometimes if you have one or two 3D printers. But what I have noticed in colleges overall, and my biggest findings is the programs are almost completely dependent on a group of one or two people, meaning that because there is such a, potential lack of knowledge around, how to get started with this, you really need to have someone on campus that is championing these programs, and the champions at these universities are the guys that are driving the success of it. And I think what I found is that, you really, if you are that champion at your school, there's tons of resources. Everybody wants to help you get started with these programs. And I think one of the problems is the lack of access to those resources. So, we do things like these webinars so that we let people know, hey, call us, so that we could help you out and, tell you either what we found, what other universities are doing to have successes at their schools. But again, it does take a proactive person in order to do that, to determine success for the universities. Because like I said, almost every university has a 3D printer, but not every university has that champion. So that 3D printer ends up kind of sitting there. But you have, schools like Duke University, who I would probably say has one of the best champions in the country as far as really working very, very hard to give access to every student on campus to the 20 3D printers they have in their lab. And they're using, our software to do that. But regardless, it's a challenge to train those students, to manage the process of 3D printing, because it's still a very manual process, loading filament. The hardware that's out there isn't perfect, and there's tons of questions about, what's the best hardware, what's the best software. And again, without that champion there to be researching and really diving into these types of programs, curriculums, I see less success without those champions. But with the champions, there's some really cool things happening at universities.
So just to kind of summarize, and thank you, Charles, not just talking about use cases, but talking about successes we've seen. The most successful K through 12, most successful universities we've seen, especially US, have been, a program where at least one admin took it very, very, a personal interest in this field. Like they kind of became an expert. 3D printing is not like 2D. You can't just go out and buy an HP printer and it's a tool or, just a part or an appliance in the classroom. The 3D printer is a tool, something much more powerful than maybe CNC milling or laser cutting, in that it, someone has to really know how to use it well. And with that, then you can combine it with that content strategy to really get the most out of it. And that's when the students and really the classroom get the most gain. Now, before we move into any other sections, is there any kind of questions around content? If you have any questions on, maybe an idea you have, a question on maybe something you've seen, please put it in the chat, and then we'll try to dive into that before we move on. And we could always circle back to the content side. No questions at this point? Okie dokie. So I'd like to move, Charles, into hardware. I feel hardware is always one of the more interesting questions. And by hardware, guys, we mean 3D printers, like the actual printers. If anyone in this webinar today has a printer, has any opinions, feel free to kind of chime in. But there are a lot of choices, and it can be a bit tricky. So Charles, I'm going to give a high level of each and just kind of dive in. So some of the schools in the U.S., we've seen. Oh, there's a question too. Are there effective? I'm going to read it out loud. Are there effective examples of applications you've seen by schools for used by schools for special needs students, aka a printed object to help tactile learners? Absolutely. We've actually seen some quite interesting use cases for kind of special needs. I know, for instance, even on Thingiverse, if you type in different pieces, I want to say they have like a Braille learner for one of the pieces. And there's been, I can't remember the exact articles, but I've actually read some great stuff on being able to print different objects that can be held to convey different thoughts. Charles, I don't know if you have the research tab open, but I'll actually would like to follow up with this question in our resource email, maybe send out some links to some stories. Because I've actually read about a few different examples, specifically on helping maybe tactile learners with printed objects, because that's where 3D printing shines. For instance, just a use case that's relative is recently someone that was blind had been unable to see. They were able to take a CAT scan or an MRI of a newborn, her newborn child, print that and hand that to her, so she could hands-on feel kind of what her newborn looks like newborn will look like, because she couldn't see the CAT scan. I know that's not an exact fit, but that tactile learning, being able to use 3D printing to influence that, yep, it's real and it's useful. And we'll follow up with that in the email.
Yeah, I'm looking for some links now.
Okay, and then that's same question again. Okay, and if there's any other questions on this, we'll again come back to it.
You can maybe go into the use case of I
have another question, actually. Sorry.
Okay.
So just one other question before we move into hardware. I see a question from Enid. Is it important to have a 3D printer in the room, or do you think to order a part and bring it in the class is enough? That is a great question. I'm giving my opinion right now, and with everything I've learned and everything I've been involved in, the most powerful every time is having the printer. And I say that because when the student, when you hand a student an iPod, when you hand a student a computer, they use it. It's great, whatever. It's super cool. When you put a 3D printer in front of someone and they watch an object materialize out of what was an idea, taking a physical idea and turning it into a physical object, it blows my mind still. And I've seen, we've taught seminars to younger, like 6-year-olds, 8-year-olds. They just want to stare. It's better than a TV. It blows their mind. So if capturing the student's attention is really important, and I think that is in the classroom, you don't want them to get bored and start throwing the objects at one another, then having the printer in the classroom, if it's a luxury your school can afford, yes, the answer is yes. Now, having printed objects in the classroom when you can't have a printer, say budget, you can't afford the budget. A printer does cost money. I understand. It's still really powerful to see a 3D printed object. To be able to touch it and manipulate it and knock on it and different materials. But you do then run into some of the traditional obstacles in education. The students may get bored. You're losing a lot of the really what makes it so enthralling. Just captures the imagination. Great question though.
Yeah, absolutely. And I completely agree with you. It's one of those things that, you could show somebody a 3D printed object and then try to explain to them how that works. But it never truly gets across until you see it. But when you see it in 5 seconds, it's so much easier to understand it that way. And like you're saying, Aaron, we have had these classes of elementary school students that they just sit there and stare at that printer for pretty much hours at a time. I've seen students do that. So I think, having the 3D printer there to really conceptualize not only obviously how that object is being built, but it also gets their imagination going, because they can understand the concept of X, Y, and Z and what that means as it builds up and the different things that they could do with that. So I think, I think seeing a physical 3D printer in action is really important to, the engagement of students.
I saw someone had raised their hand in the chat. If you could do me a favor, just put your question in the Q spot or the question mark spot. It'll help us. For some reason, it's not letting me call on you right now. I apologize. If there's no more further questions on that, and I'm sure we'll have more questions, I'll move kind of into hardware because if we're talking about having a printer in the classroom, it's probably good to know what types of hardware are available. So there's a lot of options, and we'll do our best resource-wise after this to send out a breakdown because there are so many different printers where this can get tricky quick. So here in the U.S., we've seen a ton of brands. Some great low-cost options are the PrinterBot Simple Metal, the PrinterBot Play, the PrinterBot Plus. I'm just naming brands by them. I know they do different things in education, like discounts for schools, different pieces. And it's a typically under $600 price point, which is still expensive, but it's for schools on a budget, it's a good starter printer. Now, again, giving my opinion on different pieces here, the PrinterBot, terrific printer, really good also for teaching just kind of how the printers move because you could see a lot of what's going on. Definitely one of the ones worth checking out. Some other, a ton of other printers we've seen here in the U.S. Obviously, if you've done any research on 3D printing, you've probably ran into the name MakerBot before. MakerBot in particular, I've not really used some of their newer printers, but I can speak to the MakerBot Replicator 2. Their older generation printer. You can typically, as a school, even find used. It's a much cheaper option, especially if you're willing to, spend, maybe get something for much cheaper. You could even kind of refurbish it if need be. And it's a really low cost printer to service that older printer. And that's the Replicator 2. We've seen that in a lot of the schools we work with, specifically the universities. I'm not sure why. They're just very, very prevalent there. A brand that we've also seen more of recently is a Dutch brand, Ultimaker. We've seen more of them again in the university aspect, less in the K through 12, more in the universities. It's a kind of a higher end printer, but it's really useful for not just the maker community, but like designers, artists, building really fine parts. One printer I should mention, I've not really used it a ton, but I've actually seen it in a ton of schools because it's really useful for jewelry and any sort of resin printing, is the Formlabs printer. Again, just kind of naming different brands we've seen as we've talked to different schools. The Formlabs, I think it's called the Form 1 Plus or something of the sort. From my understanding, is a good contrast, SLA printer to what everything else we mentioned was FDM. Charles, there's so many brands. I'm trying to name as many as I can for research here.
I mean, when it comes to getting started with 3D printing, especially if it's something that, you're not 100% sure of, you want to get your first printer for the classroom. You don't necessarily want to spend $5,000 and commit. It's really, really hard for me to find another option better than the PrinterBot for a starter printer, meaning for the price point, you're almost always under between $600 and $700 for the decent size model with the heated bed. It's got pretty much all the functionality you need. And the great thing about it is you could drop it off the counter, it could hit the ground, pick it back up, and it'll keep printing. And
I do not recommend that. I will be clear. That is not recommended, though.
I don't recommend you do that, but especially for the school environment, it's very easy to see. It's an open kind of printer. There's no sides on it, so all the students can see it. It's got a great price point, and almost always I would recommend upgrading from there. But for a starter printer, it's really hard for me to suggest anything but the PrinterBot, just based on quality, price, and resiliency of the printer. And I would say the majority of the schools that we work with at least started with a PrinterBot or a MakerBot. I mean, but that was probably the Rep 2s or 1/5 gen depending. But I would say those are probably the two main options I see as starter printers.
And there's a few more, but you're definitely right. We've seen a lot of schools start with a PrinterBot and then not upgrade, but maybe go, if they need something bigger, they switch to a different model, or they have both. It's kind of like that intro level. Dan, you just put a question in the chat. You're looking for a beginner printer, cost effective. I'm going to mention the Prusa i3. Do not worry. That's what I was going to get to. That's a good point in the chat. I'll jump right into that. Now, you've mentioned the Mini 3D, the Polar 3D, and the MakerBot. I've actually just read a ton of information on the Polar 3D. I have not personally seen one as of yet. I have heard good things as well. I know it has a circular build plate instead of kind of the square, like the plate moves with it. So it's a bit unique too. I know Polar 3D is also doing a lot with kind of the educational focus as well. So that is something worth checking out. I can't speak to its personal effectiveness only because I've not printed with it, but I have heard good things. So that's a good one. Dan, to finish out your question, the MakerBot, I recommend the older one only because I know it. I don't want to speak to their newer ones because I don't know enough, and I know there's been other things that have kind of came up with it. And now the Mini 3D, I think maybe the one I'm thinking of is the Micro M3D. It's a unique printer. It's a really cool one. It's so small and it's very, very cheap. For me, like, it depends kind of the use case. It's a really, really definitely a cool starter printer, and the price is very, very affordable. Again, having not done a ton of printing with it, I don't want to recommend something I can't personally say I've touched or printed with, but I do know it's very, very affordable. Now I'm going to just kind of go through these questions one by one on the hardware side, because this one actually is near and dear to my heart. I love the Prusa i3. Call me biased. That's something we have a bunch of. We've built a bunch of the kits. They are very, very useful. It's a great kit, and it's also something, it's something you can do with the students. Not every educator wants something so involved, and if you are that champion, it is a wonderful recommendation, and that's also affordable. If I don't know if anyone's international joining us today, it's like even cheaper out of Europe, because BQ makes the Prusa i3s, as do a few other people, and they can be got for pretty cheap. Beyond just the BQ Prusa i3, there's also the Wanhao Duplicator i3, which I've heard great things about. I think Maker Farm makes a Prusa i3. There's probably another brand I'm forgetting. I apologize. And these Prusa i3s are a great RepRap style starter printer. Like I said, the only caveat on that is there's definitely more hands-on because you're building a kit. The other printers we're mentioning are typically assembled. So going down the line, I see Kevin's question, the Simple Metal kit. Agreed. As we mentioned, the PrinterBot Simple Metal is a printer, we have a bunch of, we see a ton of schools with them. Again, it's another good kit for the students to build together. Both, just to, make sure everyone here kind of is well informed, both the Prusa i3 and the Simple Metal kits have really good instructions too. So, it's not something you're going to buy and be left alone. There's great support in the forums. There's great instructions out there. It's something as an educator, you can build on a Saturday and be ready to teach your students, in a week. It's not that high of a learning curve.
Yeah, and kind of going back on that point too, as far as like support goes, especially if you have questions as you're new to 3D printing, I think that the PrinterBot and the Prusas are a good choice because there's a ton out there. There's a ton of resources for you, as opposed to maybe going to Kickstarter and finding a $300 printer. I've seen a ton of these guys go out of business, not to say bad or good, but it can be frustrating and it can be discouraging when you buy a $300 printer and you call the company and the phone's dead. So yeah, from a standpoint of support and ease of use, I like the PrinterBot and the Prusas as well because you do have those resources.
Yeah, the more established brands typically have better support. Before I jump into the Q&A on the other side, I'm going to finish the chat questions. How is the support on the cheaper printers? So just because in 3D printing, there's two types of support. There's like material support when printing. I'm going to ignore that because I don't think that's what you meant. I think you mean like customer support. It's a mixed bag. I'd say like some of them are terrific. If the closer the manufacturer is in time zone, I feel like the better response I usually get. If you're buying a printer in Europe, you're going to get better European support. Sometimes it's vice versa. I would say they're getting better. Every manufacturer is getting better at support. I think it's an initiative. But as we dive into software towards the end of this chat, like our company, we work really hard to provide great support because it's not just on a hardware manufacturer to do that. If you're using software to print, we can be a lot of help in helping you get through that process. So we try to have like live support in our platform for people printing. Because realistically, you're going to have questions. I have questions when I print still. So it's great to have a resource you can ask. Materials quality, because it's another great question. Most of these printers we're mentioning all can kind of support similar materials. The only difference comes in, and this is more of a 3D printing question, is heated bed. You need a heated bed for some of the more advanced materials, and that just comes down to, it doesn't matter if you have the Prusa i3 kit or an Ultimaker, you need a heated bed. That's the consistent, and we can follow up on that after. That's just more 3D printing specific. Great comment on the customizing the Prusa i3. You're totally right. We've seen like robot monster machines with just hacks and mods for days, E3D nozzles, there's craziness. You're totally right. And you can let the kids' imagination run, or university students. It's a wonderful printer for that type of style. I want to dive into the two questions that just came through, the Tinkerine and the Cube series. So the Tinkerine, I've seen in person. I have good feedback on it from the people I know who use it. I don't personally own one, but I do know some schools. If I'm correct, Tinkerine's out of Canada. So I know some Fab Labs in Canada that actually have that printer and have good things to say about it. I think from the feedback standpoint, what we've learned so far, Tinkerine is a well-reviewed, if I understand, maybe, I don't want to say that and the Ultimaker are similar, but like they kind of look alike too. And from my understanding, it's a good printer. But again, not personally used. I'm just going off our research. The Cube, the Cube series. 3D Systems makes good printers. I don't know much about the curriculum. I don't know much about the Cube series. The only caveat I would say is using 3D Systems products, you're typically locked into 3D Systems everything through the line. I see the question, the all-in-one package, the higher price. Just you're kind of committing to one piece. Part of what we're a huge fan of, and when we dive into software, we'll go deeper, is you shouldn't have to buy and be stuck with a package. Software allows you to change that. If you buy an Ultimaker and you decide to buy a printer bot, you should have a software that works with both. If you buy a printer bot, decide to add a Prusa i3, it's great if you have a system that works with both. 3D Systems, they might make terrific stuff, and I can't go say anything negative at all, but if you're buying their printers, you're typically stuck with whatever they're going to give you support-wise and whatever their platform releases, which in 3D printing, how new this industry is, I'm not going to say that that's the best choice or wrong choice. It's kind of whatever is right for your school. If you're already using 3D Systems for all of your stuff, maybe it's a perfect fit. Charles, any other hardwares you want to add? Because I'm sure we actually missed a bunch of printers. Like I know, I'm going to just name a few brands because they're worth researching. Robo 3D, I've heard good things about. I've not really used it a ton. I just have read that they're kind of more of a place in schools. Type A machines out of California. I know it's very large, which actually one of the original questions is, what about large build size? I know I'm missing a few brands here, probably a ton of them.
I think you hit most of the big ones. And the Cube series is a very popular printer, but like Aaron was saying, it is the one printer of everything that's been discussed that is as closed source as could be. Meaning, it does depend on like what you're looking to do with the program, and that's why it's a really difficult question to say like what 3D printer should I get. Well, it's like where are you as far as like your desire to tinker or modify, what you're doing to be able to use these different materials. Oh, maybe I'm not necessarily interested in doing any kind of different materials. I just want to make these certain things. And then the Cube is great. But if you're like, hey, I want my students to be able to maybe use copper fill or wood fill and do some different cool things. And as new materials come out, you could use those on that printer. That's the one printer that you are completely closed off. And again, it's personal preference. It may be a little easier to use. And I think they do have some pretty good support as a company, but again, personal preference. And that's one of the toughest questions about which printer should I buy. It's really, where are you? Where do you want to go? So we've had, kits. You're talking about building kits, which is the complete opposite of a Cube series. So everyone's a little bit in different spots here. And that's the way it is right now.
I do have another printer to add. I've not personally used it, but I think they actually have a curriculum too. NVBots out of Massachusetts. I think they do have a curriculum that comes with the printer. I've not personally used it, but I do know that they're trying to do some things around that. All that being said, as we dive into software in a minute or two here, the goal is no matter what printer you purchase, no matter what materials you plan on using, and no matter what software you use, again, your primary business driver to make 3D printing successful in your school is what are you going to use it for? If you have no plan, it's going to be kind of hard, only just because the students, their imagination can run, but you have to have something you can, kind of lead them in the direction of. So all these printers we've discussed can fulfill the job as a printer, and more printers are going to come out. It's inevitable. There's a new printer every day. The curriculum and the content will drive how that printer is used and how great, those pieces are. And that's, my opinion in many ways, but we see curriculum influence printer buying decisions. If you're going to print large objects, if you're going to print medical, objects, like large things, the printer bot might be a little slow, maybe, or it's not the perfect fit because it doesn't have a huge build plate. And the MakerBot replicator too might be a better fit 'cause it has a bigger build platform. If you're printing math objects, like things that can be counted and manipulated, printer bot might be perfect because it's very affordable, can be brought in for that grade 2 question. Same thing with the Prusa i3, affordable, it can be built with students and they're really going to feel invested in the project. Any more questions on hardware? Otherwise, I'm going to kind of dive into software, design software, our type of software, different pieces. Let's see here. Cool. And if there's any more questions on this, and I'm sure there is, we'll circle back to it, or you could always follow up with us individually after this call. So software, that is another huge piece of the holy trinity of 3D printing. And I would start with one of the best free design tools, and I mean design, the ability for the students to manipulate the objects, is Tinkercad. It's free, which is a good thing, from a design tool standpoint. If you're not familiar with Tinkercad, I think they're an Autodesk owned product. It allows the students to have accounts, and it has tutorials. It is kind of geared towards being able to use in education, something you could teach the students. Charles just put the link in the chat if anybody wants to check that out. And it's a really good entry point, for lack of a better term. Anything you want to add on Tinkercad? Because it's something I still use. I use Tinkercad to build things every day.
As far as what would I want to add on Tinkercad? I think, me and Tinkercad, I absolutely love Tinkercad whether you have never seen a design software before or whether you're a professional designer, I've seen some of the best designers I've ever met open up Tinkercad and modify something quick. It's really, really just, it couldn't be a cooler program. And, we would love to have Tinkercad integrated into our software, but, yeah, from an educational standpoint, it's so easy to use, and one of the really, really cool things about it is it's browser based. You could use it in the classroom. Students can go home, log into their account, all the files that they had there, they could modify, go to a different computer. Like, from an access standpoint, ease of use, ease of teaching, they have modules on the site that help you teach. There's tons of materials. Almost every teacher I know that has some level of 3D printing program in their school has used Tinkercad, and from like I said, ease of use yet super, super powerful program. Absolutely, I think Tinkercad is one of the coolest things ever.
So Sergio just put an interesting thing in the chat, because actually it's something I've not explored, but I've read about recently. Is Onshape, their free version. Onshape is a incredibly powerful cloud tool. It's for design and collaboration. We've just recently integrated with them in being able to print through their platform and vice versa. I've not used this tool, the one you just mentioned, but I will actually try to research it after this one. Onshape, if this is true, I'd like to learn more about it, but that would be a valuable resource because they do a really good job at visualization. Specifically, I could imagine in the university level, he mentioned the mechanical area. It totally makes sense. So Onshape, definitely worth checking out. Some other programs, design programs, SketchUp. I'm not sure if anyone's familiar with that. At one point, SketchUp was even owned by Google. I think they're their own company now. That I'll dive into that series too, but someone just mentioned 123D design. If you guys can see me here. So SketchUp is another terrific one, which has different functionality. Another good design tool is 123D design. Someone just mentioned that. And not just 123D design, the whole 123D suite. I use 123D Catch to sometimes take 3D scans of my camera. So it's a pretty cool series. And again, this is all design focused. Now, A powerful resource as well for design tools and software is being able to download files from like Thingiverse or other platforms and then change those. That's something we see a lot of educators using right now is, teaching students to being like download a file, maybe add their name, modify it to fit a specific project. It's kind of a good beginner's project. And that's just something we've seen. I mean, more on like the K through 12 entry level, but even in the university, if they're just getting started with 3D printing, these are really good kind of access points. Find a file you love, let's modify it. The power of 3D printing is personalization, or it's one of the main powers. So it's a good starting point. Any other design tools before we dive into like our software, printer software, and other pain points? Charles.
I think you hit it spot on.
Cool. Any questions around the design tools? And I really appreciate the people who are adding different ones here in the chat. If there's any other ones you'd like us to look at, or you suggest for everyone, please add them. This is meant to be collaborative. You guys know different things than we do. We're trying to share our knowledge, but please share with us, because we'd also like to test these things out and help as we talk to other people learn more. I did hear of a new tool. I have to suggest it. Not tried it. It's by Thingiverse, or by MakerBot, I think, or Thingiverse, MakerBot, same thing. It's called Jumpstart. I have not tested it, but I did see it was a link on Thingiverse.com, and I think it's a design tool. Charles, have you tested it?
I've seen videos of it, and it's kind of goes back to what actually we started using Tinkercad for, which was the thing that I was always super interested in, and a lot of questions was 2D to 3D. Can I draw a picture and 3D print it? And I remember when we first started, there was no tools out there to do that, but now there is, and I know MakerBot does have a version of that. I think that's what the MakerBot version is where you could actually scan a 2D, piece of paper, draw black ink. You could pick it up off the page, and that's also something that you could do with Tinkercad. We just essentially convert it to an SVG, which is just another version of a 2D file. You put it in Tinkercad and just pick it up off the page. So yeah, there's other really cool tools, and I believe that's the MakerBot Thingiverse version, is 2D to 3D. Okay,
and then Lori, you just presented a good question in the chat in the question area. Is a Fusion 3D? Yeah, so the Fusion 360, that whole Autodesk suite. Terrific. We've actually tried the student account. It is a great tool. I think of that more on the university side. I've not actually seen that in like the K through 12 classroom yet, but maybe there is educators using that. The Fusion 360 definitely, though, is another one we've seen placement. I should mention, just because I kind of missed on some of the university's tools, we do see Rhino. Rhino is another powerful design tool. Blender. Charles, any other like big name ones we've seen? SolidWorks. Can't whiff on SolidWorks. That's another tool. We do see a lot of use in the university level, not K through 12. I do want to put some level of delineation there.
Yeah, besides the huge suite that Autodesk has, I think Rhino is probably the biggest professional tool that I see.
SolidWorks is everywhere too. Okay, and we'll come back to the design tools, and I feel like that's like in itself kind of an entire conversation. We're going to talk more about printer software now. So this is where we live. 3D Printer OS, in the quickest nutshell, we're a 3D printer management software. One of our goals is making it super easy for schools to bring in 3D printing. One of the biggest pain points we've seen for educators is, you go to a 3D print show, you see 100 different brands. It's super exciting. But what printer do you buy, and how do you know comfortably that if you buy that printer, you don't have to reteach a new workflow to your next printer you purchase, your next admin? It's frustrating. It's kind of scary. So our software works with almost all the printers we discussed today. It's in a standard way of really unifying all your workflows under one platform. It's not a design tool. Tinkercad, all those are completely separate. It's meant for actually managing your 3D printer workflow. And this becomes more important as you go beyond maybe one printer and more than 10 students. So particularly we work with schools like Duke and like Purdue and people like that, and Florida State, because if you have 3 printers and you want to share access beyond maybe 5 or 10 students, it's just hard. So we're able to do things like create work group codes and share that out with a bunch of people. Make it so on the student on their first day of school can get in their packet of information. Hey, this is how to access the school's 3D printers. Because again, as we started this entire chat with, access to the printers is great, and then you need the content to really drive you to use them. But if you have access from the printers from day one in a school, and then the admins have an easy way of managing that, you can focus on the content, not on the hardware and fixing the printer and fixing material situations and setting people up manually. The energy should be put into content, not maintenance. At least that's kind of our mindset. Well, after this chat, we'll also send along a link, to kind of overview how we work in the different contexts. But if there's any questions on it, because we don't know what your guys' setups are, we're more than willing to kind of dive into it. Otherwise, I was going to talk more again about, software use cases individually. So any questions? Yeah, please throw them in. Oop, 1 second here. Cool. And you guys are all invited to try our software. We have a free version. It's something we have used in a ton of different schools. Slicing, preparing files, model fixing, all of those pieces are free. You can go to 3dprinteros.com and try it out. And one thing we mentioned, and I want to reiterate from the beginning, is support. Schools typically need more support because there's a lot of questions. So we really do try to focus on that. That's like a big part of us. Beyond our software, today we want to be objective in today's chat, not just talk about what we're working on, but other printer software. For some of the printers we mentioned today, you're going to be using a variety of softwares to kind of complete that workflow. And I should mention those. Model repair, that's an important piece of 3D printing because when you teach your students, they might design something terrific, but it might be broken. It might have a hole. There might be something that makes it unprintable. Another good resource is NetFab. Charles, if you could put a link. But yeah, NetFab has a basic version, which can repair files prior to printing. Another free repair tool that I use is MeshLab. It's a little tricky to use, but for an admin, it's worth checking out. Really, really great for taking 3D scans and resizing them. We teach a class where we have students 3D scan objects and then, modify or print them. And it's a powerful tool for allowing them to do that kind of quickly. And then they can print them, through our system or some other. Charles, any other specific kind of not just repair tools, but parts of the software workflow we should mention? Maybe Cura, if you want to dive into Cura.
I mean, Cura is probably one of the best as far as like ease of use goes. But just like you're kind of mentioning, getting from the actual design to the 3D printing process can sometimes be very cumbersome because a lot of the times your designs that you're grabbing from the internet are open source. Someone designed them and just put them out there, and it may be really cool. You put it, you drop it on the print bed, but it's off into space. It's way too small. It's way too big. So Cura is another absolutely great piece of software that's super, super easy to use from a scaling standpoint. And again, that's something that we understand was a challenge and continues to be a challenge with the 3D printing process as far as getting from object to print in the smoothest way possible. So we've built tools and a workflow into our site that attempts to make that as easy as possible. But I think between Cura is a great one. MakerWare, of course, if you have a MakerBot, is a tool that lacks some, but also makes it very easy to get started.
Now, I saw Sergio just popped in here and said Mesh Mixer. Mesh Mixer is awesome. Again, if you're an educator, for the design side specifically, and some of this preparing like supports and such, I would recommend checking out the Autodesk Suite. I think they also offer like free or if not highly discounted educational discounts. So the Mesh Mixer is terrific. The Autodesk suite of products 1, 2, 3 and that whole group, terrific. I'm just trying to think if there's any tools we might have missed, and please keep sharing them in the chat. This is informative for us too. Is like the different tools people are using. Trying to think if I missed any. There's so many. No, I mean, again, if you guys want to share them in the chat, great. Otherwise, I know we're running kind of short on time today. It looks like we have only a few minutes left. Is there any other general questions? We do webinars on like general 3D printing stuff. Today, we wanted to keep it school focused because this topic is incredible and near and dear to our heart. But is there any general questions, any questions about what we've covered? And like I said, we miss anybody, follow up with us personally. We'll do our best to get back to it.
Or is there anything that in the future for our next webinar that you would want to hear about? Is there anything that we didn't talk about that maybe we could talk about in the future? Definitely let us know.
Yeah, throw it in the chats. We appreciate it. And also, if I have to mention it because we do it. If you're in New York, we do teach in-person classes in New York. Feel free to join us. We'd love to have you. Oh, wow. Great one. Sorry. 3D Slash. That's another terrific one. Thank you for mentioning that, Lori. 3D Slash is, I would say it's like where Tinkercad is. It's another great design tool. It's free, interfaces well with a lot of different softwares, and it's very intuitive. 3D Slash, another terrific design tool. And we'll try to organize this in the email we send out after this into different sections. So you guys have like, here are the design tools, here are the printer tools. Here are some of the printers we mentioned. Here are the resources we talked about. Because this is there's a lot. We covered a lot of information today.
Yeah, 3D Slash is pretty cool. So Aaron was saying it's very much it's along the same realm as the Tinkercad, but what's pretty cool about it and what a lot of students like is it's very Minecraft-esque. Would you say, Aaron? Meaning everything is built on blocks, so it's just building blocks, just like Minecraft.
Speaking of which, how do we not mention Minecraft? It's crazy. Sorry, we missed a huge one. Minecraft is an awesome tool in the K through 12 and even later. Minecraft is like almost readily exportable to 3D printing as well. So 3D Slash is one tool, which is terrific. And as he said, similar, or both of you said, similar to Minecraft. Minecraft itself is a good educational tool. The students like building Minecraft villages. The creeper from Minecraft, let me show you guys here. I 3D printed, I don't know if you guys can see that, but yeah, this is a coaster, I made on the Ultimaker. It's the Minecraft creeper. It's everywhere. I didn't design this. A student did, or someone much younger. So it's very, 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 very cool. Any other questions? I see one here. From Brendan, 3D printers have a lot of moving parts. Are there any particular parts that tend to wear out sooner and require maintenance more often? Wow, that's a great question. You're totally right. Yes, the extruder, and that's kind of a whole comprehensive piece, but the extruders do, because there's filament coming through the extruder, they do typically tend to wear out, sooner than maybe like the body of the printer. For some of the printers we mentioned, that's cheaper to repair than others. And typically it is kind of intuitive how to do it. And I don't know if guys have heard of Instructables, but Instructables has a lot of repair guides for how to repair these type of things. Another thing we see typically break down is stepper motors. I apologize. That's a confusing topic in itself, like feeder and stepper motors. That's something we could dive into in depth. It's another part on some of the printers we see kind of wear down just as you put different materials through, and maybe students are changing it out and not necessarily paying full attention. Charles, any other parts you want to add? Because there's so many parts we've had to repair on printers.
Yeah, I would say without a doubt, hot ends number one across pretty much every single printer brand is, I think we've kind of determined right around 200 hours is pretty much the standard for hot ends, meaning whether it get clogged over time and you start seeing a little bit of problems. So having a printer that's easy to replace the hot end, I think like our MakerBot Replicator 2 takes 5 minutes. The PrinterBot would probably take 5 minutes to replace, but you have some printers that are pretty tough to take apart and can be discouraging if you can't get that hot end off, because once that, that's the last point of entry, I guess, or exit, if you will. So as soon as that gets clogged, it backs up everything in the system. And I think that's probably the number one piece that we see. So,
actually, Lori just chimed in with a really, I didn't think of it in the same way. It's actually the one we see the most, leveling the print bed. That is actually, if you're not paying attention to it, one of the biggest cause of failures in prints. Leveling the print bed, I want to say I'm doing it almost every day, and it's not because you have to. It's just like I'm neurotic at this point about it. I don't think of it as a part wearing down, but you're definitely right. Attention to leveling the print bed, very, very important, because with that alone, you're not laying a solid base, and it's hard to troubleshoot your printer if possibly the print bed's not level. Other things can go wrong. You're right. There's moving parts. But the good news is a lot of the printers are getting more intuitive, a lot easier to use. The print beds stay level longer. The extruders stay strong longer. They suggest their own maintenance, and they are getting better. We're seeing improvement, and I think that's almost industry wide. Let me see here. So I saw a few different software suggested. I'm going to check these out. I just Googled Imagine 3D briefly. I don't know much about it, so I'm going to have to learn on that, and it looks very cool. Same thing with Printcraft. Thank you guys for the suggestions. We'll put these on our resource sheet. Being that we have like 1 minute left, any other questions? Otherwise, we just want to take a moment to thank everybody for joining us. It's Friday. Thank you for coming and joining us to talk about 3D printing and software and education and hardware. Because you guys care and because you showed up, this is why we're so excited about 3D printing and education. People are really taking it seriously and wanting to bring it forward. So thank you guys. And Charles, anything you want to add?
Yeah, just the same thing. Thanks, guys, for coming out on the afternoon on a Friday and for interacting with us. And everyone had some really great questions. And it's always great to see the different questions and different levels. It seems like from beginner to experienced was in here today. And really appreciate everyone and also everyone giving feedback and other suggestions. Not waiting on us to put stuff in the chat. So really appreciate it, guys. And we will be doing this again very soon.
One more thing, if anyone missed it or someone joined the chat late, the video will be available on our YouTube channel, the 3D Printer OS one, a little bit later today. Martin Zipek, thank you for mentioning how late it is there. Good night to you. I think Martin's in Austria. But this will be available on our YouTube channel for anybody that missed it or joined late. And again, thank you guys for joining. Any follow-up questions? I'm Aaron at 3D Printer OS. Charles at 3D Printer OS. You can email us, send questions, or you could even go to our website and just send it through our contact form. We'll do our best to get to them. Thank you, guys. I'm going to go sign off for Friday.
Thanks, guys. Have a great weekend.
Bye, everybody.